When we're dealing with web programming, as I've said many times, there's actually two different computers involved. We have dealt entirely on the client side up until now. This is the web browser that the user uses when they're viewing your web page, and it deals with technologies like HTML, CSS, and now JavaScript. All of these things are running on the user's computer inside the web browser. And this means that it's all sort of out of our control. We really can't make many decisions about what we're going to do. We have to use HTML, we have to use CSS, we have to use JavaScript, because that's how browsers are defined. We can't get at their files, we can't run actual programs on their computer, we can only send instructions to the browser, and then the browser decides what to do with those. And the browser is going to be very, very careful. It doesn't want us to be able to do malicious things to the computer. Consequently, the client is a very protected space, a space that we can't do a whole lot, and we really don't have access to sort of the bleeding edge computer processing on that side of things. On the server side, we have full control. We can do anything we want. We can run anything we want. And that makes it a desirable space if we want to be efficient. In this unit, we're going to learn how we script on the server side, how we can do dynamic things when we're generating that response. So remember, the basic server-client arrangement always has the client sending requests to the server, HTTP requests, and then the server sends a response. That's all there ever is to it. When you generate that response, you have the opportunity to run some code, and that is precisely what we're going to learn how to do. So, in this basic introductory unit here, we're going to talk about the server again a little bit. Look at it first as just a static file server, which is how we've been using it up until now. Then we'll learn the idea of it becoming a more dynamic server where code can run first. And when that happens, there's a new HTTP response that we're going to have to learn about, the 500 response. We've seen the 200 response, that means everything's a-okay and here's your file. And we've seen the 404 response, which is the I couldn't find what you asked for response. 500 now is going to be a new one that we'll have to learn to deal with. And then finally, we're going to learn a little bit more about what languages we can use when we do server-side scripting, and we'll focus mostly on the far and away the most popular one, PHP. So let's review. We're going to talk a little bit about what the server and client are doing when they exchange things, and first we'll just talk about a static file server. This is a server that has files on it in a folder that it can give you as you request them, and this is what we've been doing up until now. So you've seen this basic arrangement before. The client computer, essentially the web browser, sends an HTTP request to the server. And that's essentially just the name of a file. It says, here, give me this file. The server tries to find that file, and then it sends back a response. That response will include a code and possibly the contents of the file you asked for. That's all there is to it. And up until now, that's all we could do. Now, I did talk about how this gets a little more complicated once you can do asynchronous requests. You can send a request to the server where the server actually returns data. But even when we did that, we were still doing static requests. We always requested a file, and the server responded with the contents of that file. Now, in that case, the contents might have been JSON rather than HTML, but we still then received them, parsed them out, and turned them into something useful. It becomes a little more complicated in that environment, but it really doesn't change anything. Let's look a little deeper into this exact situation. We're still talking about a static file server, but what is it really going to do? The HTTP request comes into the server here. What the server does is it looks for that file, and it says, does that file exist? If it does, it responds with the 200 code, the HTTP response code 200, as well as the contents of the file. So response with the file, with a particular file you asked for. So that'll be an HTML file, a CSS file, a JavaScript file. It can really be anything you want it to be, but the most common thing are those technologies because those are things that the client computer, the browser, will know what to do with. Now the other possibility, even in this static situation, is that you asked for something that's not there. You ask for a type of file that doesn't exist. Something's wrong, you've got the wrong path, you've got the wrong file name. The server looks for it, doesn't find it. In that case, you get a 400 response, and usually it's the famous 404. All of the 400 responses are some sort of failure response, and typically they are some sort of resource unavailable response. 404 is specifically file not found. I looked for it and I couldn't find what you asked me to look for. This happens, you probably had it happen yourself visiting normal servers, and as well as occasionally during this class if you try and go to a particular point that you can't reach. So this is all the more complex it gets. We've seen a lot about what the browser can do once it receives the file. It goes through all sorts of fanciness to render the file, to apply the styles you've specified, to even run code, namely JavaScript, and use that to do all sorts of cool things. It can even send additional requests and receive them without re-rendering the page. All of that happens client-side. Let's take a little bit closer look now at what the server can really do. It can run code just like the client can, and it can make a much more intelligent decision about whether or not the file simply exists, and to give you back something that is perhaps a little more useful. So this is when we are dealing with a dynamic file server. The server can do a lot more, but also more can go wrong, and we're going to have to learn how to deal with both of those things. So remember, when we have a static file server, it really only check it's doing is whether or not the file exists. You'll get a 200 response along with the file contents, or you get a 400 response, usually a 404, and nothing else. When we are dealing with a dynamic file server, and you request something that is a dynamic piece of code, which in our case will be PHP, it's going to first attempt to compile that. Let's assume you send an HTTP request and it's for a PHP file, specifically a file that ends with .php instead of .html or .js or .css. If it ends in .php, that tells the server this file is written in PHP code. Now, it could be written in lots of different things. It doesn't have to be PHP, but that's what we're going to be using, so I'm going to use that as my example. It knows, the server does, that PHP needs to be compiled into pure HTML first, and that's what it does. It takes the PHP file, it runs it through essentially a translator that runs the code and generates pure HTML. Now, HTML can itself contain CSS and JavaScript. We've seen all of that. So it's the full sort of panoply of languages that the browser can interpret that could be generated here. But generally, it's all going to fit within that standard browser-understood HTML standard. It will then send that. It does not send the PHP. It only sends HTML because that's all a client can use. Again, it might have CSS or JavaScript in it, but it is still things that the browser understands. The thing is, compilation is complex. Some of you may have worked with compiled languages before. It all depends on what your experiences have been. If you've worked only with JavaScript, though, you probably haven't. A compiled language is a language that basically is translated once, translated from its language into some other language that it can be directly used by the next step. Most often when you're using compiled languages, you're actually compiling down to ones and zeros, bytecode that can be run right on the CPU. That would be a native language like Java or C++. Those all compile down to bytecode. However, PHP compiles to HTML, basically. And some people wouldn't even call that compiling. They'd call it translating or something to that effect. But for my purposes, I'm going to call it compiling. During this step, lots can go wrong. And if there is a compile error, then the server is not going to send the HTML. It's going to assume something went wrong. So this is where we still have a decision. If a compile error happened, something was wrong with your code, basically, it's going to respond with a new code we haven't seen before, 500. Now the 500 codes, there's again many of them, but most typically it'll just return the generic 500 response, and that means internal server error. There was an error on the server while it was trying to fulfill your response. And it does not send any other information, it just sends that. So if there was a compile error, you're going to see a 500. It's about as useful as a 404. There really isn't anything the client can do at that point other than to call up the people that run the server and say, hey, what went wrong? We're going to see these lots while we're working because we're developing the pages. Things will go wrong, you'll make mistakes with your PHP, and you will get 500 errors. Those errors are very hard to deal with, or at least you have to take an entirely different approach than we did with JavaScript errors. They happen on the server, and only the server knows about them. So if you try and figure out those errors on your own, using only the browser, you're not going to see a thing. The browser doesn't know anything other than the response was a 500. It doesn't know what went wrong, and it can't. The server is the only one that knows, so we'll have to look in a different place. Now, if everything does go okay, it'll get the usual 200 response, and what it serves is the result of compiling it, which should just be HTML, CSS, and JavaScript. It doesn't actually exist in a file anywhere on the server. It was created on the fly in response to the request. The request asked for something that was dynamic. The server generated the dynamic response and immediately sends it out. Now, the server will occasionally do clever things to cache responses so that it doesn't have to recompile them every time. You can't say strictly it's not stored anywhere on the computer. It might be. But it had to be generated at the time it was requested. So the server is doing more work to fulfill that request. It's important to keep in mind. But with that more work, of course, comes considerable more power. You can do a lot more with your response. Now, I find, from a programming standpoint, that this relationship, at least when you just sort of view it from the browser, is hard to appreciate. It doesn't look all that different from, say, JavaScript. When we're doing things with JavaScript, it looks like dynamic things are happening. Things are happening on the fly, and it feels very much like a responsive thing. The thing to keep in mind is that your computer, the actual computer that's running the browser, is doing all that work, not the server. And that is an important difference. If you get that sort of model correct in your head, I think it'll make the server-side scripting part of this make a lot more sense. The key reason we want to do things on the server is that the server has more flexibility. It can run any language, it can do anything we want it to do because we own the server and operate it. It is considered a sort of demilitarized zone where anything's allowed. The client, on the other hand, we cannot access anything other than the browser. We can talk to the browser, tell it what we'd like it to do, and the browser could even flat out refuse if it thinks it's insecure. So because of that lack of control on the client, the server becomes a much more powerful place to do things. So with all of this in mind, let's put this in action. Very often what you need at this point is you'd need an actual server. You'd have to go out and have one set up. We might have one set up for this class that you could go and access, and we will eventually have that. There will come a point where we can't avoid it anymore. But right now, because of what we've set up in the past unit, we don't have to do that. As I've mentioned before, we actually are able to run a server locally. That means both the server and the browser are running on our computer at the same time. They're considered two completely separate things, and the relationship feels very much like an actual server-client relationship. And that's going to make this unit a whole lot easier to get through because we'll be able to access both of them at the same place.